Vera Mays here from the Learning Commons. Today our topic is basic factoring. So there are 4 basic strategies that you want to start with, and then when you get further on you'll learn others, but this should get you started and actually should be valuable no matter what math class you're in. So let's look at the first type. The first one is looking to see if there's a greatest common factor. What do they all have? So when you look at this, you look at the numbers 12 and 8. And you ask yourself, well, what number goes into both of those? And you say, well, this is 4 times 3. This is 4 times 2. Since they both have a 4, 4 is the number we're going to pull to the front. And then I look at the x's. This one has 3 of them, but this one only has 2. So the most that they could share is that smallest exponent. And let's look at the y's. I see 2 of them, and I see 1 of them. Well, the most that they both share is 1. Now this one has a z, but this one doesn't have a z, so I can't pull that out as something that they share. So when I look to see what's left behind, really when I pull this common factor to the front, I'm taking each term and I'm dividing it by that. So 12 divided by 4 is 3. I took 2 of the x's out to the front, so that leaves 1. I took 1 of the y's, and that leaves 1. And I didn't touch the z's. And then from the 8, if I divide that by 4, I get 2. I pulled 2 x's out. They only had 2 x's. I pulled a y out, and I only had 1 y. So that's all that's left behind. So when you're doing the GCF, pull the biggest number, but it's going to be the smallest exponent that they both share. Move this a little over. The next one that we're going to do is when you see 4 terms pop up, you're going to use the grouping method. And it really doesn't matter the order, but some of them work out easier. I'm going to try grouping. Get my pen to talk again. Grouping the first 2, and then grouping the second 2. So again, we're going to use what we just did with the GCF. What do they share? Looks like they both have some x's, and the smallest amount would be 2. So open a parenthesis and ask yourself what's left behind. So it had 3 of the x's and we took 2 of them, so it leaves 1 x. Here has minus 2. I took all of his x's. And then the next step you're going to do is bring that sign straight down. It doesn't matter if it's positive or negative, bring it straight down. And what does 5 and 10 have in common? Well, they both have a 5. And if I factor and divide this by 5, I get x minus, if I divide this by 5, I get 2. And now you'll notice, if we've done this right with grouping, you always should get a factor in both of these big groups that matches. And I call it the magic factor or something. That's what's special about grouping. So now what you're going to do is pull that factor out, open a parenthesis, and let's see what's left behind. So on this first big group, if I were to factor this away, I'm left with an x squared plus, when I factor it out of the second group, I'm left with a 5. And that's how using 4 terms and grouping them 2 at a time, it doesn't get so overwhelming. You can look at just 2 things. It doesn't stretch your brain too far. It doesn't make your eyes look all the way across the page. 2 at a time, 2 at a time, and then compare the 2 big groups. And if you've done it right, they'll have something that matches. All right, the next type is looking at a quadratic with 3 terms, and first coefficient or the last coefficient is a 1. So we're going to use a method that's sometimes called guess and check, sometimes trial and error, and then I'm going to show you that I have a smiley face here on the page for a reason, to show you how to know what to do with your signs. So let's go ahead and open a parenthesis. The first one, the only way we can get an x squared is an x and an x. And that's why this method works so nicely. Now the 45, if I look at the ways I can get 45, I have 1 and 45, 3, 15, 5 and 9. That's the only ways I can get 45 to multiply. So I want to look over here. I want something that has to do with a 4. Well, if I add these guys, I don't get 4. If I subtract one from the other, I don't get 4. I don't get a 4 here, but I do get a 4 here. So I'm going to use a 5 and a 9. The reason I put this lovely smiley face here, is because if you notice, the two groups that we have there look kind of like his eyes. So we're going to give him a nose, and we're going to give him a smile. When you multiply the pieces on the nose together, you get a 5x. When you multiply the smile together, you get a 9x. When you combine those, you want to get a negative 4. Because the sum is negative, you want the larger one to be negative, and you want this one to be positive. So that says the positive had to go here, and the negative had to go here. It saves you the time from foiling it all the way out if you just use your nose and your smile to do your check and get your signs. All right, one more type. There's no ones here, so no coefficients that make life easy for us. So there's two methods that we use on campus. One is similar to the trial and error or the guess and check, and the other one's the AC method, which was invented, from what I understand, by the Chinese. So I'm going to do the AC method because you may not be as familiar with it, but the thing I like about it is it takes some of the guesswork out, and it gives me a process that I can work with every time. So you're going to do, if you think about the basic quadratic equation with the ax squared plus bx plus c, the first coefficient is a, the last one is c. So you're going to take a times c, and in this case, 3 times 5 gives us a 15. So I'm going to build another table like I just did with that 45, all the ways that I can figure out that will give me 15 when I multiply. So 1 and 15, and 3 and 5. We want them somehow to give us a 16. So it looks like if I deal with 1 and 15, there should be a way I can combine them and get a 16. So this is where the interesting part comes in. You leave your first term alone, and what you're doing is ripping that middle piece into two terms. So we want it to be a negative 16, which means we need a negative 1 and a negative 15. So negative 1p, negative 15p, plus 5. If I were to add those back together, I still have that negative 16p. I haven't changed the problem. It's just like doing a puzzle, kind of picking the pieces back apart. All right, then we're going to use grouping, because now we have 4 terms. So we can combine the first 2 and the second 2. When I look at the first 2, I see they have a nice p in common. Take 1p out, it leaves me with a 3p. P divided by p leaves me with a 1. And again, like with the grouping method a while ago, whatever the sign is, just bring it straight down. You don't care if it's plus or minus. When I look at 15 and 5, I see that they both have a 5 in common. So it has the effect of actually pulling out a negative 5. So if I take a negative 15 and I divide it by negative 5, I get a positive 3p. If I take a 5 divided by negative 5, I get a negative 1. Remember, a second ago I said we're going to be looking for those matching terms. Well, here they are, 3p minus 1, 3p minus 1. So we're going to factor that to the front. When we look at the first group, if we factor that out, we're left with a p. We look at the second one, what's left is the minus 5. So this is 4 different strategies. And usually you're going to look at this every problem you have. It doesn't have a GCF. Sometimes that's all you can do. But after the GCF, you look at what's left and said, is this something I can do? Can I take it any further? Can I use grouping on it? Is it a difference of 2 squares or some other method you might get to later? If you have 4 terms, it's always a good idea to use grouping. If the first term, the first coefficient, or the last coefficient is a 1, you're going to use kind of that guess and check. It's a little bit simpler method. If the coefficients aren't 1, one of the ways I really like the best is to use the AC method. Your teacher may also have you use the guess and check. Some teachers like one method better than the other. I say sometimes do it both ways and make sure your answer matches. So I hope this is helpful. If you want to come in, get some more help, we're here. We're happy to help you. And we also have a lot of handouts online in the virtual learning commons on factoring with more examples from each of the different areas that you can practice. So have a great day. Talk to you later.